Tutor example 2. So I've solved the example 1. Now let us move on to example 2. So for this example, we are going to find the factors of a given number by using computer programming. So write a computer program to help students generate the factors of a given number and comment if the number is a prime number or not. So would we'll be given a number, let's say 9 for instance, and we use a 9, we generate the factors of 9. Then after generating the factors of 9, we give a comment whether it's a prime number or not. Okay, so that is a very interesting project to do with. So let us go to our Chrome, our Visual Studio Code, and open our Explorer and create a new Python file. So tutor underscore example2.py. So let me close these examples. Okay, so now that I have this example page, sorry for this magnification. Okay, so tutor example 2 py.py. So what we are going to do is, one, we need to take an input. So this is my algorithm. Then two, we need to generate the factors of that input. Then three, we need to comment on it. So the comment is not a prime number or prime number. So that's the comment. Okay, but then this algorithm is too simple. Okay, but then I want to leave it like this because it's a simple program. But before we start the program, the question is, what is a factor of a number? So let's use 9 as our case. We already know that the factors of 9 is 1, 3, and 9 itself. Let's look at another example like 10. The factors of 10 are 1, 2, 5, and 10 itself. The factors of 11 are 1 and 11. Now the factors of 15, let's say 20, are 1, 2, 4, 5, 10, and 20 itself. So the question is, what is common amongst them? So what are the common things you've noticed amongst them? Now, if you notice from here, all the factors are less than or equal to the number itself. There is no factor greater than the number itself. So that's one thing you should take note. So 9, 10, 11 has no factors greater than themselves. So one, we need to know that, then it means that the factors are always between 1, are always what? From 1 to the number. Okay. So if we need to loop, then we have to loop over a range of what? 1 to the number. So then the range we'll be working with is, the range will be 1 to the number, but we know number plus 1. So that's the range we are going to be working on. So every factor we are dealing with is from 1 to the number itself. Okay. Then the second idea is that, now if you take the number itself, now to make your code very fast, if you take out the number itself, you realize that the remaining factors of the number is less than half of the original number. So it's half or less. Example, when I take out 10, all the remaining factors are 5 and below. 6, 7, 8, 9 are not factors. If you take out 20, the remaining factors are below half. If you take out 11, the remaining factors are below or equal to half of the number. So it has to mean that if we take out the number itself, all our factors are actually even going to be half of that number. So then what we are going to do is we can take the number and divide it by 2. Okay. And when we divide it by 2, but then we want a whole number. Okay. So we take the number, I'm coming. We take our number, we add 1 to it, and we divide it by 2. But this will give us a float, but we want an integer because the range function takes in integers, not floats. So we double divide it by 2. That means floor division. So if we have a number like, let's say 7, we add 1 to it, giving us what? 8. And we floor divided by 2, we get what? 4. So when we get 4, it actually means that we are looking for the factors of 7. Factors of 7. And we know that, but then we are looking from 1 to 4 because we know that the factors of 7 are going to be from 1 to 4. It's never going to be greater than this, greater than 4. So, and already it's only 1. Secondly, we also know that the number 1 and the number itself are always factors of the number. Okay, so by default we don't need to verify that whether 1 and the number itself are factors. But then let's stick to so we can ignore the 1 and we can ignore the 9 and we focus on finding the 3. We can ignore this 1 and ignore the 10 and focus on finding the 2 and 5. We can ignore this 1 and this 11, and if we don't find any other element, it means a prime number. We can also ignore this 1 and this 20 and focus on what is in between. Okay, but then let's deal with a more general and simple case. Okay, so let me clear these ones and see. Okay, so now that you have the idea that we are going to loop over a range from 1 to the number, but then if you want to go more technical and make your code more faster, then you cut it into half because definitely the factors of that number is not going to be greater than half. Okay, but then let's focus on the main deal. So first and foremost, let's assume that we are working with the number 9 and we know that our final answer is supposed to be what? 1, 3, and 9. Okay, now if 1 is a factor of 9, it means that when you divide 9 by 1, the remainder is what? 0. Okay, so for example, when we take 9 mod 1, the remainder is 0. 1 will go into 9 times, remainder 0. So 9 mod 2, the remainder is what? Now 9 divided by 2 will give us 2, 4, 8, remainder 1. Then we have 9 mod 3, we get a remainder of 9 mod 3, we get a remainder of 0. Okay, then we have 9 mod 4, 4 to 8, remainder of 1. Then we have 9 mod 5, and 5 will give us a remainder of 4. Then we have yes, 9 mod 6, and we get a remainder of 3. Then 9 mod 7, we get a remainder of what? 2. Then 9 mod 8, we get a remainder of 1. Then 9 mod 9, we get a remainder of what? 0. So you realize that the factors of 9 are what? 1, 3, and 9. Realize that this and that and this. Okay, so you realize that all those with a remainder of 0 are the ones that are actually the factors of 9. So if we divide a number by 9 and we get a remainder of 0, then it means it's a factor. So given this logic, let us write a simple if statement. So we say we can say if 9 or the number num percent 1 has a remainder of 0, then we print what? 1. Okay, then we can say if the number percent 2 has a remainder of 0, then we print 2. Then if the number mode 3 has a remainder of 0, then we print what? 3. Okay, we can keep on going on till we hit 9. But then what if this number changes to 10, 15, 100? Then it means you have to repeat the if statement forever. Okay, so we are going to use a for loop. So instead of repeating this action, we are rather going to use a for loop to repeat this. Okay, so we will rather say that so let me comment this one out. This is just an illustration so that you can get the feel of the meaning of the for loop. Okay, so we rather say for the iterable value I in the range, and we know we are starting from 1 and we are ending on num plus 1. Okay, semicolon. If the number percent the I is having a remainder of 0, then print what? I. Okay, so this for loop is doing what we're trying to do with writing a lot of if statements. Um, so if you take a look at, okay, let me remove this. So if you take a look at this if statement, series of if statements and the for loop, they kind of are doing the same thing. But what is changing is, you see, 1, 1. Now in this second set, it becomes 2 and 2, 3 and 3. If we continue, 4 and 4, 5 and 5, and 6 and 6. So we get to the 9 that we are interested. So this value that is constantly changing across the series of if statements is what we call the iterative variable. Is what the iterative variable is the one that keeps on changing. It changes according to the iterative list or whatever you've given it, whether range, string, or list you've given it. It keeps on updating itself and perform the same action over and over again. So this one prints out when we are to run this code. What you are going to get is a list of all the factors of 9. So we have 1, 3, and 9. Okay, but then we want them to appear horizontally. So I put end is equal to with a space. Okay, so once I have this, it prints them 1, 3, and 9 horizontally. Okay, so we've solved our problem. Okay, generate the factors of an input. We've solved it simply, but we need to comment on it. Now, the comment is whether it's a prime number or not. Now, if it's a prime number, as we see here, all prime numbers have only 2 factors. Okay, all prime numbers have only 2 factors. But here we are having so here what we are doing is we are printing it to the screen. We are printing it to the screen. But what we can do is we can add it to a list. Okay, so we can have a list. Let me call it LST. I can't use the word list because the word list means something special to Python. List is an in, if, else, what is it, print. They are all special words to Python programming, so you can't use them as variable names. Okay, so I'll use something like LST and I start with a square bracket. So what I'm doing is, anytime I find the I to be a factor of the number, I would say LST dot append. Append means add it to. the list for me. So add I to the list for me. Then when we are done, let me see if I can print the list lst. Then let's see what happens. So when we run this, 9 is already, so we printed a list of the factors by using the append method. Later on we'll go deep into the list as a function. Now if you make a mistake and you put the list inside a for loop, okay, what it means is that anytime the for loop is starting, this list should be cleared and be emptied and start all over again. So if I'm to run this, we are only going to get 9. Yes, because every time the loop runs over, the list is being started all over again. So you have to put this list outside of the loop so that it doesn't affect it. You just only update the loop. Okay. So now we have all the numbers. But then if we don't want to see the brackets and the commas, we put an asterisk here, unpacking. We use the asterisk to unpack the data. So we have 1, 3, and 9. Now we need to make a comment. Okay. So from here, once we print the list, we would say that if the length of the list is greater than 2, then print what? Um, not prime, not a prime number. Okay, not a prime number. But then if else, print prime number, something like this. So let's run our code and see. So 139, not a prime number. Okay, so this one, instead of putting in 9, we can put in input. Okay, but then we have to convert the input into an integer. So input, enter a number. Okay, so enter a number, we run the code, then it asks us for a number. So when we put in 9, we get our answer. Okay, then we run it. Then when we put in 16, we get our answer. 1, 2, 4, 8, and 16, not a prime number. Now let us put in 23, which is a prime number. Okay, 1 and 23, prime number. Okay, so I think our code is working. Now another interesting thing you can do with the loops are um, so yeah, so we'll end the video here, but I'll do a tutorial video 3 and show you another interesting thing we can do with the loops. So thank you, bye.